Ejemplo dos. Example 2. And we're going to verify that the left side equals the right side. And I'm going to actually work the left side again to get the right side, because I think it'll be easier to do it that way than going on the right side to go to left. So here, let's go ahead and take a look at all the stuff that we have. So we have a sine, we have a cosecant, a cosine, and a secant. And we know from our identities, sine A would equal 1 over cosecant A. We know cosecant A would be 1 over sine A. And we know cosine A is 1 over secant A. And we know secant A is 1 over cosine A. So we have all that information going on there. So we can choose whichever one we want to do, and it should make it a little bit easier to work with however way we do it. But one of the best ways here to work out identities is if you try to get everything down to sine and cosine. So that way it's easier to work with. You can change things over. You can cross things out. You can cancel things, in other words. So that's what I'm going to do. I'm going to change this cosecant and secant to sine and cosine so that we can go ahead and get it to work out a better way. Okay, so here, I'm going to keep the sine A on top. And I'm going to change cosecant A to 1 over sine A. And then here we have cosine A. We're going to change cosine A, secant A here to 1 over cosine A. Right, and then we're going to still keep this part over here on this side. And we're hoping that it works. It verifies, so we're going to put that question mark there just to hope that it works. If it doesn't work out, then it's okay, but hopefully it does, and that way we can actually work things wonderfully. Okay, now again with this, we've talked about dividing by a fraction. So we do keep, change, flip, or keep, change, switch, whichever one you learned. So I flipped this part here, so I kept this, changed multiplication, and we flipped this. And then here we're keeping the cosine A, change multiplication, and we flip this part. And again, we hope this equals each other, which it should. With, if they say verify, pretty much it's going to equal, but we got to show that it does. Okay, so this is sine squared, because it means we have 2a. And this is cosine squared. Not 2a, sorry. It means we have 2 sines, which means squared. And then we have 2 cosines, which means squared. Okay, so we have that part. And then we know from our trig identity that sine squared plus cosine squared is 1. So this whole side right here is 1. We know that part. Okay, so with that being said, we know that, but how in the world are we going to get both sides to, well, get the 1 to equal the cosecant squared A minus cotangent squared A? How is that going to work out? How are we going to make this happen? Because it's just 1. And maybe you're thinking in your head, I don't know, I'm so lost, oh my gosh. Again, if you get lost, remember you stop the video and then ask me for help, and then you continue on when you actually understand. So let's go back to this. There's a Pythagorean identity that says this, or a variation of this, right? Remember that part? Remember that identity? Okay, so remember we said on the last example that we can manipulate our identities as long as we don't really change the numbers or anything of that sort, or we don't like mess up the stuff, but we can manipulate it. So if we can manipulate it, we can move this cotangent squared over to this side, the left side. We can move the 1 over to the left side. Doesn't matter. Either way, we can manipulate stuff. We can move the cosecant squared to the other side, over here, to this side. It's up to you, like whatever you have to do for this problem. But we need cosecant squared A minus cotangent squared A. So if we need that going on, what do we need to do for the red part to equal the blue part? Perfecto. We're going to subtract. We have to subtract cotangent from both sides, cotangent squared from both sides. So if we subtract cotangent squared from both sides, that cancels out. So we're left with cosecant squared A minus cotangent squared A equals 1. Okay, and isn't that what we have right here? Yes, it is. Yes, it is. So I'm going to shrink this down so I can have some space, or just move it down. So what I'm going to do is take this part here and substitute it in for 1. And look at there, it does equal each other. What? Wow. It equal each other. So therefore, it is an identity. And we proved it. We verified it, that it is an identity. So therefore, since we used our identities to solve this identity, we did it. It's good. Novissima. We did it. Dun, 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 dun.